when we hear that something has a high temperature, like 500 degrees Celsius, we might assume that the object is very hot, and that if we touch it, our finger will be badly burned. However, this is not entirely true. Not everything with a high temperature will necessarily burn our finger. Something like cigarette ash has a temperature of around 600 to 800 degrees Celsius, but it can't burn our finger. But how is it possible that something with such high temperatures can't burn our fingers? Well, thermodynamics can explain what's happening. If we separate a part of the universe with an imaginary line, whatever is inside is called the system, and whatever is outside and affects the system is called the environment. Every system has its own properties. Systems can be really big, complex, or have crazy high temperature. In general, we can study different systems based on 5 properties: amount of substance, chemical compounds, pressure, volume, and temperature. While we are somewhat familiar with the first 4 properties, temperature can be a little tricky. People usually think of temperature as a measure of coldness and hotness, but in reality, it is an intrinsic property of a system that can change at any moment. In the macroscopic view, we can't say exactly what temperature is, but in kinetic theory, temperature is the result of the release of kinetic energy from the particles of the system, due to collisions with the walls. It means that when a body has a high temperature, its particles move at a high speed, and vice versa. But how does the temperature of a system change? It's simple and based on the 0th law of thermodynamics. If we put 2 systems together with a diathermic wall between them, heat is transferred between the 2 systems. Heat is always transferred from the system with a high temperature to the system with a lower temperature. This transition continues until the temperatures of both systems are equal. So, heat is a thermal energy in transit. It is incorrect to say that a system has a certain amount of heat at a particular moment, because we can only measure heat changes after the system has changed state. In addition, every system also has an internal energy. According to the first law of thermodynamics, the amount of this energy increases or decreases with changes in heat, or doing work. The internal energy of a system is also related to its temperature. That is, if the internal energy of a system changes, the temperature of the system will also change. But how does the temperature change? To understand this, we need to know a quantity called heat capacity. Each system has its own heat capacity, which shows how much heat is needed to increase the temperature by 1 degree. To better understand heat capacity, let's consider an iron bar and a lake. If we give the same amount of heat to both objects, the temperature of the iron bar will rise much higher than that of the lake. This is because the heat capacity of the lake is much higher than that of the iron bar. Well, now let's go back to the example of cigarette ash. Because of its low heat capacity, the tip of the cigarette will quickly increase in temperature when it receives heat. When we touch the tip of the cigarette with our finger, heat will transfer from the cigarette to our finger. But since our finger has a higher heat capacity than the cigarette tip, the amount of heat transferred is not enough to burn our finger. We may feel a slight burning sensation, but our finger will not be seriously injured. Well, now we know what the concepts of temperature and heat are and what the difference is.